This is lesson 8.6, solving exponential and logarithmic equations. So in this particular part of this section, when we're solving exponentials, and we're going to start there first, it's going to be really important to see if we can find, or it's going to make the problem much easier to solve, if we can find a common base. And what I mean by that is if I had something like 3 to the x power equals 3 to the 5th power, you would automatically know that the only solution for x would be 5. Because if this number is the same, then these numbers would have to be the same. So that's the kind of problem we're going to start with. So let's look at this one. 4 to the 3x equals 8 to the x plus 1. So just like in this example, if I could get this number and this number to be the same, then that would make this thing so much simpler. So here we're talking about exponents or powers. So I want to see if I can think of some number to a power, and here would be that same number to a different power. And I know that both of these are powers of 2. So I'm going to make this 2 squared times 3x, and 8 is 2 cubed times x plus 1. So since I was able to get both of these to be base 2, then I know that 2 times 3x, which is 6x, is equal to 3x plus 3. So 3x equals 3, so x equals 1. 1 is the only solution. It's the only number that I could go back and put in for x on both sides, and that would make this a true statement. Okay, let's do another one. 2 to the 4x equals 32 to the x minus 1. So when students look at this type of equation, they initially will see, oh, I just need to multiply this one by 16. But we're not talking about multiplying, we're talking about powers. So I have to try to break this down and make this number and this number be something to a power that's the same number. And I can do that because 32 is 2 to the 5th power. So I would have 2 to the 4x equals 2 to the 5th times x minus 1. So 4x equals 5x minus 5. Subtract 5x from both sides. So x is 5. So the only number that would work for x in this particular problem is 5. So at this time in the lesson, usually I have a student say, okay, what happens if you can't get that base number to be the same? So for instance, the problem was, let's see here, start again. The problem was 2 to the x power equals 7. So in this case, I can get a pretty good estimate of what x would be because I know that 2 squared is 4 and 2 to the 3rd power is 8. So this number has to be a little bit less than 3. It's going to be a decimal. So when the x is in the exponent spot, the only way to solve is to do the inverse of an exponent. And the inverse of an exponent is a logarithm. So I'm going to have to log both sides. And I'm going to show you 2 different ways to work this problem. And I'm showing you both ways because I think as you go through, you'll have teachers in college algebra or calculus that all do it different ways. So I want to show you both so you'll understand both. So one way we could solve this is to simply just take the log of both sides. So common log. Because now, once I have log of 2 to the x power, I can use the power property. I can take the x now and move it out of the exponent spot. So this becomes x times log 2 equals log 7. So now I have a multiplication problem here. So to get x by itself, I'm going to divide both sides by log 2. And then when I put it into the calculator, it looks like this. Common log 7 divided by common log 2. And the answer is 2.81. And we knew it was going to be something close to 3. But not quite 3. So the other way to work this would be, since I have 2 to the x equals 7, instead of just common logging it, I know that I can get rid of this 2 altogether if I actually do log base 2 of both sides. Because log base 2 of 2 to the x power just becomes x. And the reason why is because that's x log base 2 of 2, and this is a special case that turns into 1. And then on the calculator, I would just do math log base 2 of 7, which gives you the same answer. And the reason it gives you the same answer is because this, if you use the change of base formula, is log 7 over log 2. So you're really doing the same thing both ways. But I'm going to show you both ways on each of these problems for a little bit. Okay, let's do one more like that. 4 to the x power equals 15. We can get a good guesstimate on this. We know that it's going to be close to 2 because 4 to the second power is 16. So to get the exponent out of the x position, or out of the exponent, to get the variable out of the exponent spot, we're going to log both sides. So we can either common log both sides, or maybe you're someone that wants to do log base 4 of both sides. And the reason you choose 4 is because this is 4. So these are two different ways. So this moves the x to the front. And then divide by log 4. Over here, because this is log base 4 of 4, this just turns into x. And over here, log base 4 of 15 is 1.95. And we said it would be close to 2 because 4 squared is 16.